You have a big team. Which organization? Great. Okay. Great. I work on climate governance issues, specifically procedural rights applications to climate rights. So, so how are we going to change? Karen, so she mentioned the Open Government Partnership and Climate Working Group. So if you want to, if you're interested in Sunday, Indonesia is yes, it's at the Imran Hotel. Not too far. It's right on the river as well. It's probably 1 kilometer. But if you're interested from 11 to 1, yeah, just write me and I'll send you the invitation. Are you familiar with the Open Government Partnership? See, we're really trying to get more organizations involved in the climate and environment involved in the national action plans in the Open Government Partnership. Like I mentioned, I think it can really be another space to push these issues of better governance and rights. No, we invited them. They are part of the Open Government Partnership. I don't think they're going to be at this meeting, but they may. We actually spoke to somebody from their expressed an interest. So, and they were involved in natural resource issues as well. So, it's possible still. But that's the thing about the OGP, if civil society raise it as important, then that could give, reason. Anyway, yeah, it would be great to learn more about your work as well. Yes.
Hello. Okay, yeah, so you also have a catch box for question. Who is the main organizer?
Okay, so this is also the catch box for questions and answers. You can throw it at people, but people need to talk here. Otherwise, the sound is not going to be recorded in the last podcast.
I saw that yesterday.
Okay, great.
Scary microphone.
That's the microphone.
Yes.
Do you whack the top when you're done or something?
No, you just need to talk like that, and it has a kind of a protection effect. When you throw, the sound is blocked, but so only when people speak through it, the sounds come.
Okay.
Yeah.
Microphone.
So I cannot stand up?
No. This for people who are asking questions.
Oh.
You can throw it.
If you would like to present standing, there is a normal microphone.
Perfect, thanks, yeah.
Hello.
Oh, wonderful. No slider or be close to the computer. Hi, how are you?
No problem.
I'd like to control the movement.
Okay.
That's fine.
Do you know where it is?
Presentations here.
No, where is our?
Did you start right? You start saying you start introducing them.
Just show the pen. Where is it?
I have it on here.
Oh, I see.
This is for you then.
For the small box. There's two different presentations. You get the right.
Okay.
Is this live stream?
We have one microphone here. It should be on the website. And I'll link you to the link to the website.
Yeah, for signing up to
So
be
that's helpful.
CIFOR.org.
Oh, okay, it's better. Yes. Yeah.
Cool. Thanks. Okay, well, I think you better make a start. My name is Daniel Murdiarso. I am with CIFOR. Thank you very much for joining this side event, which is going to be very interesting. We put a very provoking title here, Rediscovering the Magnificent Carbon Storage in the Peatland and Wetland. Well, during this substar, I think peatlands got more attention now by the negotiator and the IPCC and UNFCCC processes. And we try to make sure that we respond on that from both scientific as well as networking with stakeholders. So today we have the privilege of having speakers lining up in front of us here, who is going to tell us the story about how this magnificent storage has been discovered. First of all, we will have Rosa Maria Cuentes, who is going to tell us how the expert system work to discover this. It's been a work of about 3 years, and we are happy to present it here today. And then it will be followed by a new discovery of peatland in the Congo Basin in Congo, and Simon Lewis will be following up that and explain how his experience and his group is working in Congo. And then Frank Martin will be explaining about how this new discovery will help ESA, the European Space Agency, to work with partners, with countries who really want to monitor this and use it in the reporting processes in the future. So Martin will explain how his organization will help countries to do that. So from the first 3 speakers, we will break a bit to entertain your very brief and burning questions from the first 3 speakers. And then we will continue with 2 other speakers who is going to be more of the response to this new discovery. So first of all, in the second part of it will be Diana Kobanski from GPI. Some of you may have been here the other day to hear how GPI works, and she will be telling us how the assessment is been done in order to attract the response from countries within the GPI. And then lastly, but not the least, Lou Verschow will be speaking about following up this and at least how we should move on in terms of negotiation. If you are a negotiator or representing your countries, Lou will give a kind of feedback or response on that. So with these 5 speakers, we hope today side event will benefit all of you, and we really invite you to be interactive with the group. So without further ado, Rosa, you will have the first floor.
Welcome, everyone, to this side event. Thank you for being here. My name is Rosa Maria Roman. I'm working for CIFOR. And I'd like to introduce the expert system model that we used for identifying and mapping tropical wetlands and peatlands. The next slide, please. The mastermind behind the method that I will be presenting could not make it today. It's Dr. Thomas Gumbrich. If you have specific methodological questions, please do contact him directly. He also has more information in his website. All the data presented here can be downloaded in a GIS version in the SWAM website project from CIFOR. We would like also to thank our donor for this research was funded with the US aid in a collaboration between CIFOR and the University of Wageningen. And also there are some more details about publications. Most of the data presented today and the context belongs to our latest publications in global climate change, which is open access. So you can also download it for further information. Next, please. When we started thinking of developing a monitoring system for wetlands and peatlands, several questions arise that had to be taken into context. And the first one is, what would be the basic needs if we wanted to manage peatlands at the landscape level? The list of answers could be very long, but basically the minimum things would be to have a spatial explicit data on the location of the peats, their extents, and the depths. And depths was important because it's a precursor for volume. And with volume, we could offer hypothetical, unconstrained estimates of carbon stocks, which at the end, peatlands is one of the main ecosystem services that it's providing. It's storing carbon, besides many other ecosystem services. The second question was, we would need multi-temporal analysis of the evolution of peat moisture contents if we want to look for peat degradation, okay? And also looking at the international situation on the role of peats into climate change mitigation, if we wanted to incorporate peatland into the NDCs, and if we wanted to have them into sectorial mitigation commitments, we would need to scale up. We need a method that is able to work at a global or tropical coverage that will be with high resolution to be useful for countries. And then, of course, countries that want to go into this line of direction have the challenge of developing national and subnational reference levels and MRB systems, which is not trivial. So under this list of requirements, the question to science was clear and loud. We need a method capable of reproducing global and tropical peatlands. That means location, extent, depth, with high spatial and multi-temporal resolution. Did this method exist? No, the method didn't exist. And what we saw from the existing available wetland spatial explicit data, which could be a first step of developing an improved method, was that the estimates of wetlands that existed were extremely variable. So in this publication from Melton et al. In 2013, they looked that there was a fourfold difference between area estimation in wetlands in modeled approaches, and a threefold difference in the extent of wetlands in observational mapping. So there were some options available in terms of the spatial explicit, but they were very variable. And also what we saw, the next slide, is that here you have a list of the most classical cited spatial explicit wetland maps. From Matthews and Fang, 87, to the global land cover, which is a land cover map that also incorporates wetland areas, to the GLWD, and there are some more. There is the harmonized soil wall database that is also used for mapping wetlands, and then the GMs, which is a very nice wetland map. The problem with these maps is that, as I said before, one way could be to improve the methodology behind these maps, because all peatlands are wetlands. So is there a way that we can extract the information from these wetland spatial maps and move into peatland mapping? And the answer was no, because the resolution was very high, so we have spatial resolutions that would not really be useful for country level. The coverage was global, that was good, but they were unupdated. Some of these maps are really old. And then there was not really a good relationship in the wetland categories that would allow us to move into peatland. So, and then there was there were a lot of omissions. We will see with Simon's data that the new fieldwork, not discoveries, these peatlands have been known for a long time, but the new fieldwork that verifies that there are peats there were not covered by these maps. So next slide, please. It was important then to develop a new methodology. The barriers to developing these were clear, at least definition. The first thing, what is peatland? If we want to target our monitoring into methodological approach, we need to define clearly what peatland is. And this is tricky, because as you will see, the method we use is a predictive method, and therefore we based our definition on an assumption based on the experience of the modeler. For us, we're talking about 30 centimeters thickness of peat, which is 55% of the decomposite organic matter, which would be 27% of organic content. The factor and the barrier that is constraining right now every existing wetland map and any potential peatland map at a global and tropical scales is that there is no comprehensive validation. We don't know exactly where these peatlands are. So we will show you predictive peatland map, but fieldwork is needed. We need to verify if these new hotspots of peatland that we are seeing are real or not. And then we will need to do field work to offer constrained estimates of soil organic carbon content stocks. Because right now what we can do is derive through depth volumes, and through that, with using the standardized values of carbon content and bulk density, offer hypothetical carbon stocks. It's an advancement, definitely it is, but there are certain barriers. And then methodological constraints that we knew we would be facing. Next one. So this is an expert system model which differs from other types of models like a statistical modeling, like neuronal data or data-driven approaches where you throw data and you let the data answer you what would be the predictions in terms of covariates between between numbers and between variables. In this approach, the experience of the modeler defines the process spaces that are behind the model. There are a series of if-thens that are parameterized by the experience of the modeler. So in this type of modeling, you have a predictive final map, which at the end is what we were looking for. With this model, be able to offer three types of variables: extent and depth, actually, and distinguishing between wetlands and peatlands. And what was new of this was that the resolution would be very high, that it would be tropical, which right now we don't have good, we have non-tropical high resolution spatial explicit peatland maps. And the way the model was parameterized was based on a conceptual level. So we want to identify peatlands by three properties of wetlands. We need areas with positive hydrological balances, so the water input needs to exceed the evaporation demands, so there has to be a lot of water to be a wetland, and even more than to be a peatland. The second will be that the soil moisture has to be above certain thresholds, so the soil surface has to be wet or inundated for prolonged periods. And then you have to have a geomorphological position that is able to contain the water. So these are minimum requirements for wetlands. These were even tuned up even more for peatlands. So for peatlands, you can have a stationality of wetlands in water contents in wetlands, but not for peatlands. So the water constraints for peatlands and for having anaerobic conditions in the profile that allow carbon accumulation and know the composition require constant supply of water. Could be through rain, could be through ground, could be through lateral flows. So these requirements were then set up for peatland. Next one. This is the map that was obtained with this methodology. As I said, it's a predictive map. It offers a lot of interesting information. Some of them is validated. We will see which type of data we use for validation. But there are three main messages coming out from this map. The first is that there is much more peat in the tropic than we previously thought. This is not a new story. Everyone knew that we were moving towards that. The second is that we also have a lot more volume and more carbon stocks in peatlands in the tropics than we previously thought. There was this first belief that the heat would go against peat accumulation in the tropics. Now we know that water prevents the heat from the composition. And therefore, while in northern boreal peats, it's temperature who controls organic matter accumulation, in the tropic is water. So we're moving ahead of there is no way to have peats in the tropics. That paradigm is out. And this map shows this very clearly. But more interesting, what it shows is that there is a bias in our understanding of the continental distribution of peats. Right now, when we think of peats, we think of Southeast Asia, Indonesia as the main hoster of peats. The thing is that in the predictions of this map, this goes completely to South America. South America is the largest hoster of peats, and particularly Brazil. Brazil hosts largest extents and largest volumes of peat than Indonesia. Is this surprising? Honestly not, because all these wetland maps that are available right now, they all agree that Brazil is the country that hosts the largest wetlands in the world. Therefore, saying that Brazil also hosts largest peatlands in the world is not too far away. Next one, please. This is an example of new areas of peatlands that are being predicted by this map and that need ground validation. And Africa and South America are actually the ones that have shown like almost 10 times more peat than reported in previous studies. Next one, please. All these data are available in the publication, so I encourage you to take a look at that. What did we do to know the accuracy of these maps? As I said before, the accuracy is only partial. We only have we used 275 points taken from literature about known peat areas, and we contrasted to our map. We had a 65% agreement. So there are points that we predict peat that there is no point there. There are points that there should be peat and we don't have it. So this map is the first version that has to be tuned up based on ground validation. But it's a useful map. We definitely think so. Next slide, please. What we have here is two of the most publicized pits in the tropics. Those are very large, very vast, very deep deposits of peats. The first two on the colored ones represent the Cuvette Central that Simon will be explaining and talking about them. On the left side panel and the lower one are the Pastaza Marañón in the Peruvian Amazon. On the left panels, we have the area extent, and on the right panel, we have an example of how depths are estimated in our maps, okay? So with darker colors indicating deeper deposits of peat. What is interesting about this comparison is that on the numbers that you have on the right panel, the next please, you see these two very vast peat deposits in the tropics, one in Africa, one in Latin America. And then you see on the first column, published work from field round data, so real values, and our estimates with our model. You see that our model is quite robust in estimating area extents. So we predict a bit more for the Pastaza Marañón, we predict a bit less for the Congo Basin. The next one. But what we see, and please look at the very lower panel, is our depth estimates are very high. We are overestimating depth, and because depth is the variable that tells us the volume, then we are overestimating carbon stocks. We know that. So the map needs some tuning to improve the depth. Next one, please. The thing is, and then with these two slides I finish, is that this is a first version of a very smart, well-developed, high-resolution map. But we know that the model, even though has a robust methodological development, has problems with the source data. So as I mentioned before, there are three main variables that we use to predict wetlands. One was hydrological, the other was soil moisture, and the third one's geomorphological. So in terms of hydrology, there are a lot of areas in the tropics, particularly the Amazon region, that has inaccurate climate data, or that has no available data. So it's derived from nearby stations, and this affects the variables used for the hydrological model. In terms of topography, we had run a comparison of the depths for these 275 points that we used to identify the location of peats, and we knew, looking at this graph, our map is on the X panel, and the depth of the profile points, which was real ground data, are on the y-axis. So we see that there were quite a few points that were much higher numbers in our estimates. So we knew already that the depth was overestimated, and we affected it by halving a bit the maximum depth, but still we obtain higher values. The problem with this is the topographic data used to run the analysis of depth. It's the shuttle radar topographic mission that is tuned for tropical conditions, but it has erroneous responses. The model, the data itself, the source data, has problems on areas with high forests and with lower water bodies. So it's a problem with the source data, the same that with hydrological. The last one, also, and this is for you to understand, this model is useful, but it has its limitations. This is just one version that will need to be tuned in the future. And ways of tuning it would be through regional parametrization, because right now we use one model for the entire tropics. So best next step would be to use data that is parameterized for regions. Okay. The last comments is that we also have issues with soil moisture. So there are areas with heavy persistence of cloud cloud coverage. The moisture index is based on optical MODIS. Even though it's smartly done, it has some problems with severe cloud persistence. And then we use only 1 year to parameterize the evolution of the moisture content. And we chose a year that was La Nina. So that might also affect the final results in terms of peats in this map. Thank you very much.
Thank you, Rosa. Simon, who will follow that?
Hi, everyone. My name is Simon Lewis, and thank you very much to CIFOR and European Space Agency for inviting me and putting this on. So I'm going to talk about that the Central Congo Basin and a central depression called the Cuvette Centrale, where we've been working for the last few years. So what is peat? It's good to step back just a little bit and say, okay, it's partially decomposed plant matter. So something is stopping it being completely decomposed and respired back to the atmosphere. That's usually low temperatures and waterlogging. So they're the impediments, which is why people didn't think there was much peat in the tropics. But actually that waterlogging and very nutrient poor water impedes the microbia and impedes the decomposition, and therefore we can see this accumulation of partially decomposed plant matter. Some of the highest carbon storage ecosystems on Earth, so incredibly important for conservation in terms of carbon. And there was no standard definitions, and in our work we said at least 30 centimeters of soil with greater than 65% organic matter counts as peat. So as we've heard, some big wetlands in the tropics. The second largest wetland in the tropics, almost identical size to Germany, is in the Central Congo Basin, the Cuvette Centrale. It's almost all swamp forest. So it's overlain by tall tropical forest, waterlogged underneath. And if you hunt around in the literature, there are a few reports saying there's peat here, there's some peat there, or there's histosols, which might be peat, but might not be. But when you go through that literature over the last 50 years, there's no single report of a geolocation or a village or a river. So we could go and actually get the peat, bring it back and run it through the lab and check that there was definitely peat. So that's what we wanted to do, and then produce a map. If there was peat, then we'd produce a map of how extensive it is in this region and how much carbon is stored next. So our philosophy, and the real problem here is that no satellite can detect peat. And that's why we see these huge overestimates, because they just can't see way down below the ground and see how deep your peat is or what's really going on below the ground. So we've got an area the size of Germany. We think there's peat in there somewhere, but we don't know where. So we have a really needle in a haystack type problem. So we try to narrow down on this by saying, okay, you need inputs into the system to accumulate peat. So we're looking for our swamp forest. We need year-round waterlogging and low nutrient status water to impede the drainage. So we use a radar and ALOS satellite to look for waterlogged areas. And we can exclude the slopes and look at the places where the water is likely to accumulate as the places that are likely to be waterlogged all year round and most likely to accumulate peat. So that's why we have our digital elevation model, to get rid of the slopes and look at the depressions. Next. So then we could then pinpoint where we think a priori there might be peat, and then go and see if there is. Which means trekking out there into the Central Congo Basin. And here's a picture of the, on the right-hand side, the swamp and what it looks like on the inside. Next. And here we are. We did find peat, which was good news. So we use an auger that pushes down into the ground. And when you twist the chamber, it locks the chamber in and locks some peat in. And then you pull it back out. And you repeat that going all the way down until you stop finding peat below. And then you can take that back to the laboratory, make sure it's more than 65% carbon, and then you can work out what the true depth of the peat is at that location. And you run big transects through the swamp to find out how deep it is and a bit more about what's going on in the system. So we use this first expedition to then hone our ideas and hone our satellite searching for locations of peat to test hypotheses to be able to produce a much better map later on. Next. So the important thing about that area of Central Congo Basin, this is two rivers. So this is the boundary between Republic of Congo and Democratic Republic of Congo. And it's quite a straight river, and it's actually a white water river. And when that water's in channels, you don't find any peat, because actually it's too high nutrient content. This is a black water river, the Likwala, and here you find peat all around it. But this has got real channeling through here. So actually most of this water that's coming from outside the region is just traveling all the way through and is not spilling over into the swamp and therefore stopping the accumulation of peat. So these are the kind of hypotheses we can test by thinking about why the peat is forming or might not be forming. Then we can get a better map. So these are all the locations over a kind of 100 by 200 kilometer box where we went round, sampled our peat, brought it back to the lab. Next. So what did we find out? So we found out that actually of this wetland, the peat only occurs under 3 types of vegetation: year-round waterlogged hardwood swamp, 2 types of palm-dominated swamp, maximum depth 5.9 meters. Peatlands only start several kilometers away from the river access, which is why people, I think, don't know about them, because you have to really trek for a whole day, perhaps, to find an area that's got peat underneath it. If you radiocarbon date the peat, it started accumulating peat about 10,600 years ago, so the beginning of the African humid period. So when the earth warmed and Central Africa got wetter, then that allowed these basins to fill up water and slowly accumulate carbon over the last 10,000 or so years. And then you can look at just date much nearer the surface, and even though the African humid period ended in the Central Congo Basin about 3,000 years ago, it's still been accumulating carbon over the last 1,000 or 2,000 years. That top portion is quite young. Next. So this is just to emphasize how slow the accumulation rates are. So this peatland over an enormous area is accumulating at about 0.2 millimeters per year of peat. So a tiny, tiny amount, but going on for long periods of time. And most of that accumulation is carbon. So therefore it becomes large when it's been accumulating for long periods of time, which is why it's so important to keep it there, not allow it to go back out into the atmosphere, this 10,000 years of accumulation. Next. So we were trying to work out how this system works. And this is where we kind of slowed down a bit in terms of our understanding. So there's lots of evidence that it's rain-fed. So we don't see flood waves of the rivers overtopping their banks and then bringing all this water in to flood these huge shallow basins that are filled with peat. And the amount of rainfall coming in goes along with the water gauges that measure the water table, suggesting that that's the dominant source of water. But if we would expect, based on what happens elsewhere, that we would see domes across these huge areas. So the middle of the peat would be accumulating at a higher level than those on the outside. And we see this in Southeast Asia and in UK peatlands and in Northern Europe and North America. But actually, when we look at this from satellite data, so along the bottom is our peat depths every 250 meters going for 26 kilometers. And we see this shallow basin increasing from the river starting here. And then you've got a few kilometers of no peat, and then start the transect and an increase in the peat depth. But actually, there's no hint really that there's big domes here. So we're actually not quite sure how these peatlands are functioning. If we don't understand how they function, then we're not sure how they're going to change if people start interfering with these systems. Next. So in terms of going from that 100 kilometer by 200 kilometer place where we're getting some fairly detailed information, how can we go up to the whole of this wetland? So we do this by looking at satellites and trying to assess the vegetation over this wide area, and then use our field-derived relationships between presence and absence of peat to then estimate where the peatland is likely to be. So we do this by maximum likelihood classification. So we take all our ground data, separate out 1/3 of it, run the classification and produce a map with 2/3 of the data, and then compare it to our independent data, 1/3 that's been left over, and repeat that 1,000 times. So produce 1,000 different maps. And then that gives us an idea of the uncertainty of where we're really sure we've got peat and where we're not so sure we've got peat in our area. Next. So again, this is more refined about how we might use these satellite products. details are not important, but this will go on the web and is in the paper. Similar to what I said before, but a bit more refined now because we've got a lot more information from on the ground. Next. And this is the map we produced. So it's spatially explicit, and it tells us about how confident we are that there really is peat under that 50 meter by 50 meter square of land surface. And the total area of where we're more than 50% sure that there is peat, based on the data that we've got, is 145,000 kilometers squared. So of that huge wetland, second biggest wetland in the tropics, we think about 40% of it has peat underlying the swamp. So another 60% is savanna vegetation, seasonally flooded forest, which doesn't have savanna, doesn't have peat underneath it, and little areas inside this that are terra firme forest or water. We think we're about 88% accuracy against the independent data, so not too bad. But I think what's important about producing maps like this is that we can use these as a guide to go out and collect more data to rapidly improve this map. If we get places where we're really sure that there's peat and there isn't, that's going to make a big difference to the next iteration of the map. So it allows us to be much more focused than we've been previously, because now we've got some data to work with. Next. Yeah. Oh, go back one up. And then if we multiply this area by peat depth, bulk density, and carbon content from our laboratory work, then we see that the peatland stock is about 30 petagrams, 30 billion tons of carbon. So to put this in context, this is about the same amount of carbon as in all the vegetation above and below ground of both the Republic of Congo and the Democratic Republic of Congo, second largest area of tropical forest in the world. And this is storing the same amount of carbon in a much, much smaller area. Next. So to put this in context, so I've just done this top bit, puts the Cuvette Centrale complex as the most extensive peatland in the tropics, which was a surprise to me when it came out of the computer. Increases African carbon stocks from 7 to 34 petagrams. Is about a quarter of the world's carbon in tropical peat is in the central Congo Basin. So that's, this is really important for future programs in terms of UNFCCC and the RED program and conservation initiatives, and increases total tropical carbon stocks of peatland by 36% to almost 130 petagrams. Next. So just to finish, this area is very remote, but United Nations have and others have begun to overlay some of the other land use types that are coming along into this area. And actually, when you look at this, so this is the peat swamp forest, and then forest concessions laid over the top. Actually, about 20% of this peatland is already overlain by, is that me out of time? Last slide. This about 20% of the peatland is already covered in allocations for logging permits. This may look very, very different from what currently Southeast Asia looks like and the peat swamp forest there, but those pressures appear to be on the horizon. Next. So I'd just like to say, you could read all about this in detail in the paper that was out earlier on this year. And next, last thing. And I just have to say a big thank you to all the villagers who hosted our fieldwork and really taught us how to live there, because we really couldn't have done it without them. Wildlife Conservation Society Congo and Marion Ngwabi University. Also, this was a UK Congo joint team effort to make this happen. Thank you very much.
Thank you very much, Simon. Now we'll have Frank Martin to continue with the ESA perspective.
Well, good afternoon. I'm Frank Martin Seifert from the European Space Agency, and I will bring you from one exciting place in the Congo to another exciting place, which is space. And thanks a lot to Rosa and Simon who introduced already Pete to you, so I don't have to repeat this. That was a bad one. Okay, accepted. But I would like to come up with what Simon just said. Peat is not visible from space. That's true, but you can see a lot of characteristics of peatlands from space, and that's what my talk is about. Please, next one. So I'm coming from a space agency. I would like to introduce you to a new generation of data sources. You heard the data sources Simon was using, and this is the Copernicus program, which the European Union set up as one of their space flagship programs to monitor the environment and civil security. Copernicus consists of three elements: an in situ element, a space element, and a services element, and where ESA is responsible for the space component. Now, the nice thing, all the data are freely accessible for everybody, not only in Europe, for everybody on the globe. You can go to this web address and you can start downloading those data. Next one. So what is this Copernicus system all about? We have radar missions, we have high resolution optical missions, medium resolution optical missions, atmospheric and altimeter missions, and I'm concentrating on the first two because they are really relevant towards peat and wetland monitoring. Next one. So that is Sentinel-1. We have 2 units up in orbit. It's a night and day radar imaging in C-band. That's a 12 days repeat with 1 satellite, a 6 days repeat. And what you see here to your right side is the map, which is of the world mapped, how it's mapped by Sentinel-1. And most of the land surface is mapped within 12 days or better. Next one. And that brings me to with Sentinel-2, which is a high-resolution optical satellite. It's multispectral, has 13 bands, has 290 kilometers swath width, and a geometric resolution between 10 meters and 60 meters. What you see here is with 2 satellites, and we just launched the 2nd satellite, it will map the whole land surfaces in the Earth, on the Earth within 5 days, cloud permitting. Next one. And now coming, what can be done with these satellite images? You see here the mapping of peatlands in Sweden, the Stormos Kavasjon. I hope no Swede is here around to correct my pronunciation. On the upper left, the Sentinel-2 image from August, and you can delineate already the peatland there. And then you see the same peatland within the radar image. The work was done within the SWOS project from the European Commission by Jenoptric. Next one. And now I'm coming to a project supported by ESA, Globe Wetland Africa. It's a 3rd global wetland project which we are supporting from out ESA, that is starting in 2004. This is concentrating on African peatland. You see here to the right related to wetland inventory, a wetland in Algeria, and it's about identification and delineation of wetland areas, look at and detect changes, assess threats and estimated the input. And we're looking there on standardized land cover habitat classification together according to the Ramsar Convention. For more information, you can go on the website. And next one. And we are developing as well within this project a toolbox which is accessible, which makes the satellite data accessible and workable not only for the remote sensing expert, but also for new people who are new in this field. Next one. The toolbox will be available soon, somewhere in summer this year. Next one. Now I'm coming to another type of observation. We're looking there at the wildfires in Indonesia in 2015 during El Nino, detected by radar satellite Sentinel-1. You see here several areas, false color composites, and then derived from that the burnt area in Sumatra, in Borneo, and in Irian Jaya. The map, the burnt area map, is in 10 meter spatial resolution. That's the best available map of the burnt areas in Indonesia. And based on this map, next one, please. We have estimated the carbon released from the vegetation, but as well from the peat on the ground, under the ground, during this fire event. 46,000 square kilometers were burnt in Indonesia during 2015, and vegetation is released. The burnt vegetation released about 500 tons were from out the peat, which is only a third of the burnt area. Underneath is bringing almost 400 megatons of CO2 into the atmosphere. The method developed by RSS, remote sensing company, looking at the wetland international peat layer, looking at what the Ministry of Forestry from Indonesia was providing on the land cover, and then taking the burnt area from Sentinel-1 into account and coming up with these figures. Next one, please. So, after supporting 10 years Ramsar related to wetlands, we thought it's about time to do as well something about peatlands. And you will hear later on from Diane related to the Global Peatland Initiative, which ESA will support with an additional project looking specifically on peatland to improve mapping and monitoring of degraded and cultivated peatlands, addressing peatlands in the boreal zone in Europe, but as well in the tropics. And there specifically the three areas, the three pilot countries within Indonesia, what we heard then in the Congo Basin and in Peru. And working there together with users, UNEP, UNFCCC, FAO, Wetland International, and so on, to derive best practices on how satellite images can be used to improve peatland monitoring and mapping. We see this as a mitigation potential for implementing responsible and sustainable management of peatlands, preventing further peatland degradation and supporting the conservation and restoration of peatlands. Next one. So, in total, with the Copernicus system, from where I started, you will have a data source which will be not only available today, but at least for the next decades. Data are freely available. We see this as a major workhorse for the monitoring of wetland and peatland from space. We are supporting the development of open source toolboxes, no license, open source, freely available for all and everybody. And we support the GPI, what Diana will talk after me, with a dedicated project. Thanks a lot.
As promised, you have time to ask questions to the speakers, clarifying ones, short, and then, yeah, okay, Diana.
Thank you very much for exciting presentations, really experience from all over the world. I have a question to Rosa, maybe first comment and question. Yeah, the comment is that unfortunately, your statement that all peatlands are wetlands is not true. Unfortunately, a large amount of peatlands are drained, are dry, and are not wetlands anymore. and those exactly peatlands need the first attention and in mapping, because within this convention we have to address these peatlands. But this is a comment. My question was, while developing this map, as I understood, it's still under the development. Yeah, it's still the CIFOR map. Have you used also these resources from Ramsar, like the GlobeVet results, and also the national inventories? Because in reality, the largest countries with peatlands are not Brazil, but Canada, Russia, and Indonesia, because of the depths of the peat. But they are really mapped, and this is the huge areas, and they are absolutely perfectly mapped. Each peatland is mapped there, in Canada, in Russia, and Indonesia now, and also now European Maya book was launched. And now we have peatland map of Europe. So is this already in, or you need some support to put it in, some access?
Who the response? Rosa?
Thanks very much for these comments. Yes, to the first question, not all wetlands are peatlands. Yes, drained. Sorry, no, yeah, sorry. The other way around. I was discussing the mapping from a hydrological perspective. So in that sense, that was my statement. I agree with you that drained peatlands, well, I'm not sure I agree, but I see your point of whether drained peatlands are not wetlands anymore. But I agree with you. Those are the ones that we also need to monitor into the degradation status, definitely. The status of the map. This map, it's only focusing on tropics and subtropics. So all the other areas are the next versions of this map. The maps are available. So this version 0, it's already available on the website of the Swan Project, only for tropics and subtropics. So it goes down to up to Florida and down to the very south of Latin America and Africa. So there is not going to be a soon update of this. Now we're going to get feedback from ground data that we don't have, and this might be next year or in 2 years' time that the map will be on the next version. So whomever is interested into navigating ground validation of what the map predicts, it's now. Also, it's important to mention, it's only for lowlands. Okay, so we also feel very confident in saying that Latin America is the hoster of the highest peatlands in the tropics, because all the Andean and Brazilian Mata Atlantica at altitude and all these high elevations are not mapped. Okay, so if we believe we're quite conservative there, so, but that is also a different type of parameterization. That's why the model doesn't have it now. And it would be fantastic if there is any data of peats in this particular moment in time. We're more interested in the tropics, but having not mapped but ground truthed data on peat locations, we are absolutely interested in having this data. So thanks very much.
Someone from Congo? Oh, you want to add anything else?
Anyone wanted to? Can they introduce themselves?
Within the, as I said, the project what ESA will put out as an ITT towards the end of this year will take into account maps and input in situ data from the partners from the Global Peatland Initiative. We don't want to reinvent those things. We want to support the community, the users, and of course build on the knowledge of the organization, which is already there in-house.
I mean, I think just to emphasize that this, how difficult it is to map peatlands as a subset of wetlands in the tropics. So that, you know, for example, the Pantanal is the world's largest wetland in the tropics. As far as I know, it doesn't have any peat. And it's certainly not what I've seen when I've been there. And that's because in the dry season, it's just a bit too dry.
Mm-hmm. We don't
yeah. So I'm just saying, it's, you know, it's a difficult issue. And I think this question of the water chemistry inputs is also really important. We know that white water and black water areas are very different, and you won't find peat in white water areas, even if you have the same conditions that you would find it in an area with black water. So I think that's also, you can get that from satellites, but it's a whole nother layer to add to the top on top of these analyses.
Gentleman from Congo, and then last one in the back, and then we move on to the speaker. Please introduce yourself.
Okay, thank you. I'm Joseph Badevokila, a national focal point of Congo, Brazzaville. And nice to see you today because I heard about you in March, I think. Yes, and I'm not happy because I have a microphone. I would like to put the blue box. Anyway. Okay, as a national focal point for UNFCCC, I will have a lot to do this year. So, third national communication, the BER, and the technical need assessment, and also something else. So I don't know how I will deal with the peatlands in Congo with that project. Have you been involved in that kind of situation before? It will bring a change in our project, because when you see our NDCs, there is nothing about peatlands, but we have to integrate that peatland. How? I don't know. So we will need your, maybe your expertise in that kind of situation. Maybe also I have Diana and Simon, so I'm sure that we will be working together. So it's something I'm wondering about since 1 week. Okay, so it's just a question. We will need support for that. Thank you.
Maybe the next speaker will explain that, but feel free, Rosa or Simon.
So can you?
I think this is CIFOR. Yeah. Yeah. Do you want to answer that question, or do you? I think it's a very interesting question, and I think it's a very important question, that how is peatland and how is this type of peatland actually included in effective climate action? And I think that's a real challenge for people here and the scientific community and the global community. But I suppose my name is Frank McGovern. I'm from Ireland. We obviously have some interest in peatlands ourselves, as we have quite a few. And I found this talk about the Congo peatland very interesting. I was just wondering, peatlands are typically remote, and you said that is a situation. But you did also indicate there's an indigenous population there, and I was just wondering, have you got some details about the population density and how that population is working in and with the peatlands? Also, peatlands in northern hemispheres are very old. They tend to build up over millennia. I was just wondering, have you any details about the age of peatlands in the tropical area? Is it over the same time periods that you're talking about? And also, I suppose finally, the evolution of that peatland, has it reached some sort of dynamic equilibrium, or is it still growing, or where will it be if it keeps on developing?
Yeah, thank you very much. So in the terms of the time period, so the Central Congo peatland, based on the radiocarbon dates, has been accumulating slowly since the beginning of the Holocene, so around 11,000 years ago. The end of the African human period, we have a little bit of data, but not really enough to say anything really robust, that it looks like the peatland, the accumulations rates declined as that rainfall declined in the middle of the Holocene. But if we look at the last couple of thousand years, the top half meter of peat, then it appears to have been accumulating over the last couple of thousand years. We can't say anything about the last few decades or anything. What we can say in terms of the climate there is that there's very few weather stations in that area of the Central Congo Basin, but those that there are have suggested that there's been a decline in wet season rainfall. So there's been a small decline in overall annual rainfall, and actually a decline in mostly in the wet season. So whether that could affect it. So there's about 1,700 millimeters of rain in that area of the central Congo. So it's really not, it's wet, but it's not that wet. It's because there are these big shallow basins that are filling up. But if climate change reduces the rainfall, then you could see a situation where you tip it to, instead of being a net carbon uptake into the peat, then it dries out in the driest part of the dry season and then respires back to the atmosphere. So that's one of the things I'm worried about. But I think in the shorter term, logging concessions and then just opening up the forest and disturbing it, that's also probably may well be enough just to tip it to become a carbon source, alongside, you know, much larger scale drainage operations, which would really increase the rates going up. And time periods in terms of elsewhere in the tropics, in South America, typically, again, Holocene. In the Amazon, they tend not to get really old because you have these, the rivers are migrating a lot. So you get some of it gets fast accumulation and it gets eroded away by a river, and then another place starts accumulating. Southeast Asia, they tend to be a bit older, could be 20,000 years or so. In terms of local people there, there are people living there. It's very low population density because there's very, very little dry land to have a village on. That seems to, from my experience, that seems to be kind of the limiting, what limits the number of people there. And they are mostly fisher folk. So they're doing a lot of fishing and a tiny amount of crop production because there's just no dry land.
Thank you. Well, I think we need to move on with the next two speakers. Please keep your question. Diana?
Yeah, thank you, everyone. Good afternoon. My name is Diana Kopansky, and I'm honored and excited to be here with everyone. I am working with the UN Environment, and I'm the peatlands coordinator and the leader of the Global Peatlands Initiative. The initiative is a partnership of more than 20 different international, governmental, non-governmental, UN and academic organizations and expert groups. It's nice to see some very familiar faces in the audience, and thanks to CIFOR for giving us the opportunity to share a little bit more about the work of the Global Peatlands Initiative, and especially what we've been collaborating on most recently. So as you've heard, peatlands are found all over the world, and they come in very different forms, and they display different characteristics and are used in many different ways. As you've heard from the team here, peatlands are important. They really do matter. They're highly efficient carbon sinks. And although they cover only less than 3% of the global land surface, estimates suggest that peatlands contain twice as much carbon as the world's forests. Next slide, please. Despite their importance and the extent of threats that they face, tropical peatlands are one of the least understood and monitored ecosystems. So this lack of knowledge on peatlands needs to be addressed, because as peatlands become more accessible through development and as investments in large-scale commodity production increase and increasingly encroaches on the peatlands, we're going to have a big problem. This is where we're talking about this tipping point, the balance. So historically, throughout many peatland areas, poorly informed policy decisions have created situations resulting in the repeated fires, widespread degradation, and these have long-term local and global impacts on the sustainable development, human health, and well-being. The Global Peatlands Initiative, which was launched in COP22 in Marrakesh, is focusing on building a better understanding of the peat status and trends. With our partner countries and experts, we're working to ensure the maintenance of restoration of carbon stocks in key peatland countries. We started off with Indonesia, Peru, and the Republic of Congo as our pilot countries. And actually, owing to the work that's been done here by Simon and his team, we have approached and we're welcoming the Democratic Republic of Congo as well in the Global Peatlands Initiative. We aim to work together with the data that we have, with the expertise, and collectively aim to reduce global greenhouse gas emissions. We want to do this by increasing the knowledge of peatlands, looking at their extent, the changes, the thickness, the drivers of change. And we want to also be available, as Joseph asked, to support countries to look at and make efforts for their policies, improve their policies, as well as in the NDCs and INDCs. We want to help countries know about, use, test, and scale up approaches for peatland conservation, restoration, and sustainable management. These peatlands, as we've heard, have many benefits. They benefit everyone for water supply. They're enormous places for biodiversity, unique biodiversity. They're important for people and for the climate. Next. So in order to draw the attention and to the urgent need of countries to reduce the degradation of their peatlands as a significant source of greenhouse gas emissions, the initiative has started a rapid response assessment. Thank you. The purpose of the rapid assessment is to raise awareness about the threat of peatland loss, is to identify problem areas or global hotspots, including information on the extent, depth, carbon stocks of peatlands. We're also combining with other areas of expertise and looking at the drivers of the degradation and the loss, land use change. We want to link the effects of the degradation to emissions and emission savings as well. We're looking at identifying and scaling up and sharing successful restoration, protection, and sustainable use approaches for peatlands management, and looking at to examples of Indonesia and elsewhere, where we're looking at identifying policies and approaches, law enforcement and legislation that works, and where are we going to need to be, for example, in the Congos, to immediately help them with their policy response. So the rapid response assessment are assessments. There's not new research, although we are happy to include very new research in it. It uses existing science, and it helps us as a team, a global team of scientists, practitioners, policymakers, and governments and decision makers to identify the gaps in knowledge and data in order to make informed, appropriate decisions. So this is a joint effort. You saw many of the logos. We started with about 10 founding entities, and we're already up to 19. So it's a joint effort to call to action the decision makers. It's a call to action for private sector and public on peatlands awareness. We're hoping to launch the rapid response assessment in time for its findings to be considered at the next Bond Climate Change Conference. Thanks. As you can see, peatlands do matter for people, and we do hope to work together with countries to develop management and policy options to minimize the impacts of peatland degradation on people and the environment and avoid the dangerous social and climatic tipping points. Please join us in the effort to share your expertise. We have a number of members already here that have already sharing their, making their data open, available, and free. And we'd like to invite everyone to come on board and to join the team, to contribute your expertise, to contribute your passion, and to really make a change here. Thanks very much.
You may want to continue.
I can usually catch one.
Throw it down.
No, it doesn't.
Does it work now? Oh, there we go. Okay. It should work once I start talking, right? Hello? Hello? Can you hear me? Should I just speak really loudly?
No, but they won't record it.
Won't be recorded.
I think this works.
Okay.
Sorry.
Thank you. Okay, can you hear me now? Okay, great. So Daniel asked me to sort of wrap up this session and say, we had a nice review of the science and where the science is going. And so the question is now, where do we go with this now? What can the Climate Convention do to support conservation and sustainable use of peatlands? So can we take the next slide? So just looking back, I think it's worth noting that over the past decade or so, we've really seen a significant advance in our understanding of the biogeochemistry of greenhouse gas production in peatlands associated with land use and land use change. When I think of the 2006 revision to the National Greenhouse Gas Inventory Guidelines, peatlands and wetlands were sort of mostly pushed into the appendices because there was insufficient data to come up with appropriate approaches to putting together Tier 1 emissions factors, and they were still quite controversial. At the time, most of the measurements were just gross measurements of total soil respiration. There was not really a breakdown and understanding of a mechanism. This is just an example of one study where the separation between heterotrophic respiration, the decomposition of peat, has been separated from total soil respiration to understand that component of the mass balance in these peatlands. But we've made significant advances, I think, over the past 10 years or so, and I think we're moving in the right direction. We're not completely there yet, but we're certainly making progress. Next slide, please. And so in the 2013 Wetland Supplement, a number of us got together and were able to put together what we consider to be reasonable emissions factors for Tier 1 greenhouse gas inventories, okay? And keep in mind, Tier 1 is supposed to be for helping countries complete inventories when they don't have appropriate data for not significant parts of their greenhouse gas inventory. So Tier 1 emissions factors should be used for parts of the inventory that make up less than 5% of total emissions or less than 10% of the variation, of the uncertainty in their inventories. But so we have emissions factors ranging between, I guess, about 1.5 for shallow drained systems to on the order of 20 for very deeply drained systems. These emissions factors are not perfect, but they're good for what they're supposed to be used for. They're not good for what they're not supposed to be used for. Okay, and we need to keep in mind what they really are supposed to be used for. Because I see a number of publications that my site shows that the IPCC emissions factors are wrong. Right? We see that all the time in the literature, and really the IPCC emissions factors are never meant to be site specific. Next slide. We also have some reasonable attempt at emissions factors for non-CO2 greenhouse gases. We know that drainage ditches are extremely high sources of methane, and that shows up in the few data sets that did exist that we were able to find. We know that drain soils have very little emissions of methane, and that makes sense. So the oil palm plantations, for example, the measurements show no emissions, and that's a good enough estimate for this. Nitrous oxide is another story. And nitrous oxide, this is nitrous oxide, please understand it as nitrous oxide not associated with fertilizer application. This is nitrous oxide from the peat decomposition. That's what the emissions factor is in the greenhouse gas guidelines, right? Fertilizer is treated differently, okay? But so we have some reasonable estimates, and given the carbon to nitrogen ratio, I think these are not too bad as a starting point for peat. But it's really based upon very, very few data sets, and we need many more data sets, particularly on nitrous oxide, to nail this one down. And I'll show you why I think we need even more on nitrous oxide associated with land management. If we could take the next slide. This is a paper that we have in preparation right now in fertilized oil palm systems. And whereas IPCC typically applies a percentage of the fertilizer that's applied, so it's a linear response, we're seeing a very nonlinear response in this. Okay, and these very high application rates are because of something very particular in the way oil palm is fertilized. They fertilize in about a 2-meter radius right around the palm. So this is data from only in that fertilized zone. So even though the rates are on the order of 150 to 200 kilograms per hectare, it's a very little part of that hectare that actually sees the fertilizer. And that's what leads to these really high emissions on that fertilized area. So we need more of this type of data to help us refine and deal with the specificity, because drained peatlands and peatlands in general are managed very differently than any other agricultural system, than any other forestry system. It's a very specific ecosystem and a very specific type of management. So we need more data to help us deal with that. But we're still making progress. Okay, next slide. So, this is probably got animation. So so there's still some gaps. Let's hit the first gap. Sorry. So temporal dynamics. Most studies are 1 to 2 years. And if you're lucky, you hit an El Nino year. If you're lucky, you hit a La Nina year. And if you're lucky, you hit a La Nada year in between the two, right? But we don't have good long-term studies on any of these sites. Even subsidence studies tend to be on the order of 3 to 5 years. Although we do have some data from the Everglades, and the Everglades data depends upon when the paper was written. It's all over the map, from 4 tons per hectare per year to 20 tons per hectare per year. Right, and not a really good explanation about temporal dynamics in some of that data. So we need to understand changes with time since deforestation and changes with time since drainage. Because we understand that soil organic matter quality changes over time, that the peat quality changes over time. How does that affect the decomposition, the emission rate? None of these things have really been studied. We have a number of teams out there on sites, and hopefully they will continue to measure the sites. Hopefully the resources will be available to them for them to continue to measure these sites. But we need more longer term data to understand the temporal dynamics and the trajectories. Next. Subsidence dynamic. We need to do a much better job of segregating the effects of compaction, consolidation, and decomposition better. And in particular, for short-term studies, we need to understand this shrink swell. Shrink swell can give you negative and positive elevations on the order of 20 to 30% of the annual change. And so if we're dealing with a 1 to 2 year study on subsidence, if you hit a La Nina year at the end of in one period and a La Nina in the other, you're not necessarily sure that you don't have shrink and swell as part of your estimate. So we need to get these longer term dynamics in, both for the flux measurements and for the subsidence measurements. Next. We need better quantification of inputs through root senescence and litter fall. This needs to be a mass balance. At the moment, we're getting much better at measuring the output side of the mass balance. We're not getting very good measurements and many studies on the input sides of the mass balance. So we need to fill that hole. Next. And fire emissions still require much more systematic study. So emission factors need study with adequate spatial representation as well. All of the data in the 2013 Wetland Supplement come from Southeast Asia. Simon showed there are threats in the Congo Basin. I'll show a case study in a minute in Pastaza Maranhão. There are also threats there. It's not clear that these emissions factors are appropriate outside of Southeast Asia, because as we've heard, the peatlands are very different in these different parts of the world. Next. And so this is the case study for Pastaza Maranhão, and this is a study that's in press in press that shows, that just maps out some of the threats going on there. So we have threats from fossil fuel pipelines and fossil fuel exploitation in the area. Roads are going through, and we know that roads typically lead to deforestation and expansion of agriculture, drainage in peatlands. So there are threats in the Congo Basin, even though it's isolated. There are threats in Pastaza Maranhão, even though it's a very isolated peatland, and we need to take these into account and understand what's likely to happen. The thing is that because these areas are undisturbed, the approach is going to be different also from what we do in Southeast Asia. Southeast Asia has large areas of already degraded peatlands. I think that's my point. large areas of degraded peatland. So it's going to require a different approach to these areas that are relatively intact but under threats. Next. And this is just a case study also in the Pastaza Maranhão area where there is significant degradation going on in the Mauritia flexuosa swamps, where because of the unsustainable harvesting practices, basically these are very tall palm trees, and people go in and chop the whole tree down. There's a very big change going on in the floristic composition with a disappearance of palms and an increase in hardwood, and there's a bit of an impact on above ground carbon. We have no idea yet for below ground carbon how this change from a palm dominated system to a hardwood dominated system is affecting water relationships in the system, how it's affecting litter fall and carbon inputs to the system, how it's affecting carbon outputs. So again, we need to understand that some of these areas, even though they look relatively intact, are currently under threats, and we need to get out and hopefully ahead of the curve, so we're not trying to do what we're doing in Southeast Asia, which is fixing something that's already in a difficult situation. Okay, so what can the UN Framework Convention on Climate Change do? I've sort of grouped these into three areas. So there's a lot of things they can do, I think, but I think it really comes down to a couple of key focus areas for action. So the first one is to improve reporting through national greenhouse gas inventories. The better we get on reporting, the more countries become aware of it because they're collecting data on this, because they're analyzing data and reporting on this. I think is going to help raise awareness, but also help spur action. So we have the IPCC Wetland Supplement. It's a good start for Tier 1. If these things are these areas are sources of major emissions, we need to move into Tier 2 types of inventories, Tier 3 types of inventories. So we need to improve and with site specific, but we also need to build the capacity of these countries to measure and monitor their own wetlands and to assess their own emissions. Okay, so capacity building is needed to integrate these areas into national greenhouse gas inventories. We need to support the technical services, the research institutions to support national greenhouse gas inventory. As we look across the tropics, countries are gaining capacity in measurement and reporting. They're gaining tremendous capacity in remote sensing. They have much less capacity in improving their emissions factors and their carbon and converting the area assessments into carbon numbers. And this is something that I think really needs some international support to build national capacity. The more the countries do it for themselves and own the data and own the process, the more seriously they will take the threat to their own ecosystems, just as we do in ours, right? Support, and I think we really need to target Tier 2 or better for peatlands in national inventories to the extent that we can help countries get to that level. Next. The second thing I think the UN Convention can do is facilitate financial flows specifically to peatland emission abatement. Many peatland areas, as we said today, several people have said today, are intact. So approaches based on conservation and wise use are required before we get to a catastrophe. In Southeast Asia, large areas of peatlands are already degraded, so resources are needed for restoration. And we don't have good examples of restoration. People groups are just getting started with restoration, but we can't point and say, here's how restoration needs to be done. Here's what leads to success. Reflooding a peatland after it's drained is not easy. And many groups have tried and not fully succeeded to the extent that they expected to at the beginning. Okay. Carbon values need to be integrated into development planning, right? The status quo in many developing countries is not sufficient. It's not acceptable. Countries need to develop. Countries need to create economic opportunities, and much of this depends upon land-based resources. Okay, so this needs to be integrated into sustainable development with the emphasis on sustainable, and sustainable and wise use of wetlands. Improved spatial models of peat distribution based on improved understanding of peatland expression in remote sensing data are needed to support carbon conservation schemes. We've seen several mapping efforts today. Everyone admits that we still have a ways to go on improving our peatland maps and our approaches to this. We need to make progress on this. Teams are working on this. We have starting points. We need to make sure that there's support to take that through to the next steps, to the next iterations. And the current focus on above ground carbon in conservation in RED Plus actually doesn't draw the attention needed to avoiding emissions from below ground carbon in peatlands, right? So I think within the RED Plus mechanism, also expanding beyond the above ground biomass focus that currently happens should help us deal with some of these below ground issues and move us out of the terra firma forests. And finally, facilitate information exchanges and sharing of information, of experiences. We have the TEMS, we have in-session workshops. It would be useful to set up a web portal for periodic submissions related to peatlands and other high carbon ecosystems. This is already done, but it could be done, in a much more coordinated manner and much more focused on these high carbon ecosystems. And I think encouraging inclusion of peatlands in the AR5 that's IPCC is undertaking, and the special report on land use and land degradation that IPCC is taking. To the extent that the UNFCCC can push IPCC in that direction and ask specifically for assessments in these areas would be useful. So I think that's my final slide. I want to thank you all for giving me the opportunity to speak here today. Thank you.
Thank you very much, Lou. And if you have any questions for Diana or Lou, please raise your hand and identify yourself. Anybody? Yes.
Hi. Thank you for this session. My name is Tony Hartshorn. I'm from Montana State. Just your mention of the string swell reminds me that, maybe a consideration here could be to think about equivalent soil mass approaches to comparing peatlands over time, right? I mean, I'm really interested in some of the data from the Congo, which was your one core is and so there was this anomalous core. It was only 2,000 years old, and I'm interested in sort of the potential for some of these to pop, right, as the water levels drop and we have these really interesting thresholds that are crossed. It's going to require, I think, thinking very creatively about how you compare cores before and after because of this issue with different densities and depths.
I should just say about that one data point is I'm 90% sure that it's contamination. So it's a tree root that's taking modern carbon down below, and some of that carbon's got into our sample. It doesn't make any sense otherwise.
And just on this before after, the first year or two following deforestation and drainage, there's a massive subsidence that happens. In some places you could lose easily a meter or more. And there's a bit of a physical reorganization that happens. So the before after is really difficult because you're dealing with such a heterogeneous substrate, particularly before. And if you core through these things, you find pockets that are sort of empty or really slushy, and you find you hit intact wood in the middle of these areas. So it's not that easy to make these before after types of comparisons. So you'd have to be really, really creative, I think, and have some pretty good resources.
Any more questions? Gets the ball. Hey.
Thank you. My name is Angela Geck from the University of Freiburg, and I was wondering, because you referred to wise uses of peatlands, whether there are any ways in which peatlands can be used commercially without destroying their benefits.
Do you want this based on data or opinion? Yeah, if you look in Indonesia, I think there's some traditional uses for production of sago, for example, that are much less destructive and correspond to the way communities use their landscapes. So that might be considered. There's been a lot of talk about the possibility of developing polluticulture systems. I don't know that anybody's actually identified other types of polluticulture crops or products that could be produced. But it's certainly something that folks are looking at in the north, and if it could be exported to the south. I think we need to just remember that there are people living in these landscapes, and they need to have better economic situations than they currently have today. Otherwise, they're going to keep doing what they're currently doing. So I do think we need to look for constructive approaches to help them meet their livelihood aspirations. And if these ecosystems are a large part of their landscape, I think that it makes sense to integrate that into the models we develop. But I can't say today that we have models figured out or good examples of sustainable or wise use of wetlands. We have a lot of examples of unsustainable use.
I had a wise quote from the GPI session the other day. Use wetland or peatland while it's wet. Is that right, Diana?
I'd like to add that there was this congress in FAO in March about, and it had soil organic carbon management, and it has a session on peatland. And basically the idea is if you can avoid draining, just keep it as it is. But if you have to drain it, then there are certain guidelines and what is the level of the water table that you should try to keep in order to minimize the net balance of emissions. So yeah, to damage control when agriculture is imperative. Yeah.
Any other questions? You want to catch the ball?
One more thing about the wise use. The Wetlands International has actually been doing a lot of testing and best practice approaches in Indonesia. And you can actually see some of the work that they've been doing through their website. I'm not sure if anyone else wanted to add from the work on Wetlands International. Tatiana, thank you. She knows a lot about that.
Of course, if you just Google wise use of peatlands or wise use of wetlands, you will immediately go to the guidelines in Ramsar guidelines on wise use on wetlands. And also there was a book launched 2003 by IMCG and IPS, wise use of peatlands. And this is the whole bench of these decisions, because wise use is not only keeping wet, it is all landscape level solutions. Yeah, so this, well, landscape planning, so it's a lot of options. It's like wise, you know, that you don't be ashamed in front of the next generations. You know, this is wise. Yeah, I have several comments if possible. Possible or not questions? Yeah. Yeah, I'm Tatiana and I'm working with Wetlands International. Yeah, this looking at these sessions now on peatlands and all developments in convention peatlands, I would like to remember the good times where peatlands were called mires. Yeah, and not peatlands at all. And when we drafted a resolution, global action plans on peatlands for Ramsar in 2003, it was mires in the first draft. Yeah, so there were classical scientists drafting this, like Richard Lindsay from UK, Michael Steiner from Austria, and other people. Yeah, classical. There was mires. Then came Nick Davidson and crossed this all out and put peatlands ever. And then for policy, it went peatlands. And peatland, which is a wetland, is mire. Peatland, which is not anymore wetland, was always peatland, because peatland was used by peat industry usually, but not by scientists. And we were, a bunch of people were working hard to bring peatlands in the political process. First side event on peatlands for UNFCCC was in Milano in 2004. The Global Environmental Center, Faisal Parish, me, Wetlands International, and several people did it, and everybody was like looking, what is this? We don't deal with this. Go to Ramsar. Yeah, we went to Ramsar, and through Ramsar CBD bring it. And now I see that it's like gin from the bottle, because everybody is dealing with peatlands, but forget to look in the textbooks on mires. Yeah. So what I really would like the GPI does, this is bring the classical knowledge and make it popular for children, ministers, and also special scientists. Because when scientists are working with the greenhouse gases or whatever, they don't understand the peatland as an entity, as it is. Yeah, they don't understand really that it is water, peat, and biota, which are connected with each other. We can't live without each other, and which are working to maintain the whole system. And this is the longest modern vegetation succession in the world. This is succession. This is just vegetation succession, which is going 10,000 years or longer. Yeah, like underneath. Anyhow, so what I wanted to say this first is this knowledge and for awareness, of course, because without awareness in new countries who are realizing this, this is impossible. And then really to address the hotspots, because now we are all speaking about tropics because it's obvious, but we have Arctic, yeah, which is peatlands are preserving permafrost there, and this is the real. We have highlands, we have arid and semi-arid zones where the peatlands are overgrazed and people lose the source of water without even understanding what it is. Yeah, so this, and that's why for GPI, I think the knowledge, yeah, and focusing and on the hotspots, and reaching out to all conventions, not only to UNFCCC. Yeah, thank you very much.
Thank you. Diana, you want to respond?
No, I wanted to say thank you very much. You know, the teams and the knowledge that's been there, and I'm not sure if many of you were able to attend the session on Tuesday, but you could see the wealth and dedication of years of research in the room. And it's really important that people are passionate about this. It's a very important issue. I think what we need to do is definitely bring another layer of awareness, of policy understanding, a dynamic of political will that maybe hasn't been there previously. I think if we saw the slide with about 20 different organizations, and a significant number of those organizations are universities, are research institutes that have actually dedicated years and years of research on this topic. So I think in the rapid response assessment, we'll see that knowledge from the Greifswald-Myers Center, from the universities that are attached. We'll also see then in the global peatlands assessment for next year, the dynamics of the non-tropical peatlands or mires and bogs coming up. It is unfortunate that our colleagues from Ramsar and the Convention for Biodiversity were not able to make it. They are part also of the Peatlands Initiative, and they will be next week with us in Jakarta for our Global Peatlands Initiative second partners meeting. Thanks.
Simon, you want to add something?
Yeah, just briefly, I think I would just like to emphasize how difficult it is to get funding for scientists to do the basic science on the ground and get people out collecting data and running it through the labs. And actually, I essentially failed to fund this project, and only because I won a science prize that had no strings attached and what I could spend it on, that I could spend it on this, because it's so hard to find, particularly I think in Africa, where people think the Congo Basin is just too difficult to work, and it's not. You know, there are great scientists, great colleagues in universities in these countries, and you can work with them, build great collaborations, but you know, it's really hard to persuade people to fund the basic science.
Frank Martin, you want to respond to that kind of reflection?
Well, we are often offering scientists, specifically within Europe, towards the end of this year, the opportunity to get some funding to continue your research. Looking forward for your proposals.
Thank you. Sounds like a wrap up already, so I don't think I need to wrap this up. But our time is over. I think somebody else is going to use this room, unfortunately. Oh, I didn't see that. Please. There you go.
Sorry, I just wondering whether we have the Global Peatland Initiative. Is there any possibility to make it like a Global Coastal Wetland Initiative? Because this is one of the big storage for the climate change, yeah, the blue carbon, something like that. I'm sorry, Pak. So
I'd like to add to that. The definition of peatland is I didn't spend on that, but in our map, mangroves are incorporated into peats. Okay, so we have 4 different types of wetlands that add into the peat. So coastal and blue carbon would be incorporated into peat initiatives as well. Although not all mangroves necessarily are peats, so they are more, some of them are more mineralogical. And with that, I'd like to make a call to those institutions and the networks that already exist to really encourage you to use the map, to go to the SWAM project in the CIFOR website, to take a look at it, to I've acknowledged the limitations, but it's the best available peatland map that we have for the tropics right now. So I think please use it. If you have extra data, feedback on what you think the map could be improved, and it would be really, really useful. Thanks very much.
Sorry, it's not a question, it's just a proposition. First of all, I'm happy because I have the blue box now. Yeah. Okay, there is one question, not a question, but an initiative I got for myself and from someone else. Why not organizing an international conference on tropical peatland management next year in Congo? Why not? But we will need support.
That's a nice invitation. So I think that's conclude our session. So thank you very much for your participation, and let's give a big applause to the speakers. It's shown up here, the SWAM website, where you can visit the map. So please visit those layers of wetland, peat depth, etc. Feel free. If Frank Martin doesn't want to repeat, I want you to meet and greet for the peat in the refreshment. Thank you.
We would like to.
The drinks and the waiting outside. Yeah, I might be dressed as like someone else. I'm thinking about writing the email.